All right. Welcome, everyone. Please take your seats. It's so great to see you all here. Thanks for coming. This is our second last mile delivery meetup, hosted by Bettermile. The delivery industry continues to be in motion. You can read it every day in the news. You can read it every day on LinkedIn. More than ever, it's necessary that we talk about the topic, how to build a parcel delivery service as a tech product. This format is designed to bring together people from established delivery players, neo companies that just joined the market, and tech providers that offering their services. Welcome to the Last Mile Delivery Meetup. It's great to see you all here. Give yourself a hand. So now we're coming to the next level. Ingo, really excited to hear what you will tell us about location.
Yeah, thanks, Simon. Way to put on the pressure. And before I get started, I wanted to give a shout out also to Octavio for mentioning us. And I remember you promised that you wouldn't get too nerdy. I can promise that. So today I want to talk to you about algorithms for position and motion data. And you might ask yourself, why am I showing a surfboard on the slides? Fair question. As a startup, we often get asked, how do we come up with our idea? And that's where this surfboard comes into play. After exiting my last company, I spent quite a bit of time at the Atlantic Ocean coast in France and also did a lot of surfing. And that passion combined with my love for engineering made me ask myself the question, could I use all these sensors we have in a modern day smartphone to retrace the accurate three-dimensional curve of me surfing a wave? So I put my smartphone into a waterproof bag, put that into a 3D printed case, and fixed it to the top of my surfboard, and went into the water, tried to catch as many waves as I could, lost one smartphone in the process, and spent countless hours analyzing and processing the data to come up with the answer, yes, it is possible, but unfortunately it's quite complicated, and maybe a bit too complicated solely for this use case of adventure sports. But when I talked to David, who's one of my co-founders here in the back, about the challenges in food delivery and quick commerce around position and motion data, I thought, well, there is my problem that's worth this technical effort. And that's how truemetrics came to be. We support the future for urban transportation and logistics with motion and position data that we create using sensor fusion and machine learning. We were founded in 2021. We're located in Berlin, actually just a 10-minute walk down the road. And we work with customers in quick commerce, food delivery, logistics. And we're actually just new to the space of parcel delivery, and we're happy to explore this space with our colleagues from Bettermile. Short agenda. I want to show you about the challenges in quick commerce and food delivery, and I think you'll see a lot of them are one-to-one transferable to what you've seen in parcel delivery. I want to show you one solution of ours, delivery location intelligence, to help make deliveries faster and more successful. And I want to finish off by proposing some opportunities for last mile delivery. But let's start with the challenges in quick commerce food delivery. These challenges are very near to our hearts because David, before joining truemetrics, was actually an operations manager at Volt. So he experienced these challenges every day. And also, as you can see here, these companies are really struggling. The times of expansion at any cost are over, and now they have to start working on their bottom line. And to be able to do that, one of the major levers is efficiency in their delivery processes. And I want to show you two big challenges for this efficiency that revolve around position and location data. One is insufficient, unreliable data about the different segments of the delivery, and this data goes into dispatching optimization and performance management. Obviously that's a problem. And the other one is significant delays in some of the deliveries when riders struggle to find the entrance where they need to deliver. But let's get into these in detail by looking at the journey of a rider in quick commerce. So you place your order in the app, and then in a dark store, in a logistics hub, somebody starts packing a grocery bag and puts it in a shelf. And at some point, a rider claims this order. He, makes interaction in the app, and he takes the order off the shelf, and that's when the delivery process really starts. But he doesn't start to deliver right away. So he takes this bag, he puts on his gear, he walks outside, he needs to find his bike, he puts the bag onto his bike, and then he starts cycling. And this already can take anywhere from 30 seconds to a couple of minutes. And if we look at this quick commerce food delivery journey, that's a significant share in the total delivery, and a share that's currently invisible to companies that operate in this field. So the rider's on his bike and he cycles towards you. He gets to your destination, or actually he doesn't get to your destination. He gets to where Google puts the pin, and we've seen this before, right? So he gets there. He starts getting off his bike. He takes the bag, and then many providers require him to have an in-app interaction where he actually says, "I've arrived at the location," and this might actually happen right away. It might happen 30 seconds later, or it might not happen at all. The rider could forget, and I'm guilty of this. Testing our tech stack, delivering myself and food delivery in quick commerce, I've forgotten it. And what does this mean? The whole data set for this delivery becomes corrupted, unusable. But let's say everything went well. I walk up to the customer, hand over the groceries, and again, I'm required to do an in-app interaction where I confirm, okay, I've delivered. This happens typically fairly close to when I deliver, but again, it's a point of uncertainty. And this doesn't yet tell me when the rider is going to get back on his bike, and it doesn't yet tell me when he's going to get back to the depot, because he still has to go downstairs, get back to his bike, put on the helmet, start cycling, head back to the depot, and then when he gets there, he needs to swipe that he confirms he's available again for the next delivery. So what we see here is that we are lacking number of data points to actually describe the delivery process, and that the ones that we do have are highly unreliable. And that obviously becomes a problem for dispatching optimization and a problem for performance management. Because this unknown makes these companies built in buffers in their process, and buffers kill efficiency. And looking at this process, I actually skipped a big second pitfall that I think we've heard a bit about today already. So let's say the rider gets to his navigation target where Google sends him or Mapbox sends him, but that isn't where the entrance is. And we've seen that in about 15% of deliveries, there is a significant delta between where a driver is navigated and where he actually needs to enter a customer building. Sometimes, you just turn around and it's a bit down the block. Sometimes it's around the corner, or sometimes riders fail to find the entrance altogether. And this typically initiates a customer support call, and then we're looking at delays of 5 to 10 minutes. And that obviously is a killer in efficiency and time loss, and not a good customer experience. And today I want to focus on this problem with you guys and on a solution for it. And to make it more tangible, I actually brought 2 real-life examples. On the right-hand side, super typical one, we get navigated to a street address, and we see this street address or this point is actually the entrance to a larger courtyard with numerous houses, right? So then we need to enter the courtyard and find where's the house that we actually need to deliver, where's the entrance where we actually need to deliver. Depending on the signposting, that can go fairly smoothly, or it can take a couple of minutes. And on the left-hand side, this is a more critical case, actually. Here, our navigation tool, and in this case, this was Google Maps, sends us to the closest location of where it has its geocoded pin, and we've seen that in the presentation by Hammes before. It's in the middle of a building, and this building is in a back courtyard, and the closest point to it is the parking lot right next to it without an entrance to that compound. So I'm at a dead end. So here, very likely, we're going to see a customer support call that helps me find out where the actual entrance is, which is at the front of the street. And I would like to show you a solution to these problems. And we call this solution delivery location intelligence. And what we do is we automatically record and log into a database information about our delivery location. Most importantly, entrances, just talked about, but also which floor does the final delivery happen at, and where stairs or elevators are used to get there. And now we're going to get into the nerding out. Let me tell you how it works. At the basis of what we do is all the sensor data we get from the rider smartphones. This sensor data is collected by an SDK that is installed within our customers' front-end apps, typically called the rider app, the workforce app, and gets sent to our backend. And in our backend, we perform two steps. First off, we use sensor fusion to increase the accuracy and reliability of the position and motion estimate. And this is possible because we have different sensors in the smartphone that all have their strengths and weaknesses. So we all know GPS or GNSS. It's great. It gives us an absolute position on the globe. It has a bounded error, but it is prone to external disturbances. When I get close to a building, my line of sight is obstructed, my line of sight to the satellite, that position becomes bad and unreliable. On the other hand, IMUs, so accelerometers, gyroscopes, magnetometers, they're not affected by these external disturbances, but they only give me relative motion and they drift over time. But combining these two together with knowledge about the process that is behind it and that imposes boundary conditions, we can get to that higher accuracy and reliable estimate for position and motion, where our rider actually is, even if he gets close to a building. And our second pillar is machine learning to detect all the relevant events along the delivery process. And such an event, for example, is when a rider arrives at your navigation pin and he starts getting off his bike. But these events are fairly diverse because different riders act differently, different modes of transportation, different hardware. So to be able to do that accurately, we combine looking at motion state changes from cycling to stationary to walking, overlaid with the knowledge that we have about the process. So to give you an example, if I see that the rider is currently in a journey to customer segment and then goes from cycling to stationary to walking, then I know, okay, now I've switched to the next segment. He's actually going to the final stage of delivery, going to the customer entrance. And these two pillars, these algorithm pillars, come together in what we call delivery location entrance. Our machine learning models give us an exact timestamp at when the rider enters the customer building, and our sensor fusion gives us an exact location of where that is. And obviously that's helpful because if we have one of these cases where it's hard to find a customer entrance, if one rider, if one courier, if one delivery driver has solved that riddle once, next time we can route him to that entrance right away rather than to that pin in the center of a building. Unfortunately, or if you ask me as an engineer, fortunately, our algorithms don't have fancy user interfaces we can show, but we try to put together a bit of an illustration of the data to make this easier to get, easier to relate to, I would say. I'm going to play a video in a second, and it's going to be pretty fast. So I'll tell you first what we're seeing in the video, and then walk you through what happened afterwards. In the main viewport, upper left-hand corner, we see the point of view video from the rider who's delivering. Underneath, we see those motion states that are going to be changing as he goes through the process. Below that, we see the delivery process with different segments: order claimed, delivery started, arrived at customer. And the bottom right, we see a little map view of the location where he's delivering with a little pink pin of the navigation target that Google Maps gives him. So we see he's biking, and we're going to see him changing to different states in a second. So getting off the bike, going to walking, and what we're going to see happening is he basically graduates to the next stage of the delivery. So he's arrived at the customer, and he's now approaching the customer building. I'm going to let this run for a second and then talk about it afterwards. But you can see there's a door appearing on the right-hand corner. Goes into the back courtyard. Typical case for Berlin, we're getting a second door. So actually, I think it should end just about here. Yep. Actually, the first case was a tricky one for us. Because the typical case is that you sort of push open the door and you enter in a closed building, which gives us a very distinct event, but here we walk through a tunnel. So uncomfortable for us to detect, but still manageable. And then, as I already pointed out, typical data set for Berlin, I first enter the compound and then I enter in the backyard, which is great knowledge if I deliver to that same customer again, right? But also, beware, be careful. Don't link that second door to the address because, you know, depending on the customer that you deliver to, that second door might not be relevant. First door will be, second door, be careful with that. I want to show you a data excerpt of what the data looks like that goes into making these doors appear, and I did a little animation here. So what do we see here? These are two position tracks, and one is raw GPS or raw GNSS, and the other one is the result of our sensor fusion algorithm. And if we look at the GPS, we see something that's actually quite typical. So, you know, we're fairly fine in the beginning, we're going around the corner, but then as we actually are approaching the house where we want to do the final delivery, all of a sudden the track starts going into the other direction and then ends up in the middle of nowhere. Super typical for GPS. We approach a building, we get more reflection signals, which actually, you know, turns what's happening around. We get less quality signals, so we end up in the middle of nowhere. And if we use this raw data track for pinpointing the entrance, you know, our entrance again would be in the middle of a building, but in the middle of the wrong building. So, on the other hand, you see what comes out of our fused location track, and we see here that by using these other sensors, by using the knowledge about the delivery process, we can compensate for those bad GPS data point. And you see the tiny little red dot there. That's where we ended up. It's not exactly where the door is, but close enough to make it worth it, right? And yeah, I think that's already it for my nerding out. But I did want to share with you some opportunities in last mile delivery that we just kind of want to pitch and that might be interesting for the discussion later on. So I showed you in detail a feature that we are using or that we've used for food delivery quick commerce, which I think is just as valuable for parcel delivery or any other last mile delivery, you know, detection of entrances, but also other location intelligence like floor, stairs, etc., to, you know, make your delivery faster and I guess also more successful. I just briefly brushed on delivery journey insights, and this is this automatic segmentation of a journey into reliable timestamps to make dispatching and performance management more reliable and more efficient. And two other features that we want to propose that would be easily able with basically the same tech stack is what we call mapping parking locations. So same as we map entrance locations, if we know when a delivery driver gets out of his van and we know where that is, then we have a parking location. And what makes a good parking location, it's available, it's safe, it's legal, hopefully, and it's close to where we need to do the final delivery. And if you could share the parking locations of your experienced drivers with your rookie drivers, wouldn't that be great? Second one, we dubbed proof of attempted delivery. This is a tricky one. I don't know, I think we've all experienced this. We see our delivery status changing from waiting to a delivery attempt failed, even though we were at home all day long, you know, waiting for our precious new iPhone. We just went out real quick to walk the dog for 5 minutes. So who's at fault here? Did that delivery driver really just skip me on his tour? Did he maybe, I mean, we talked about geofencing. Did he maybe drive past and say attempted, but didn't even stop? Was it those 5 minutes when I wasn't there? Or is my bell maybe broken? Who knows? So to solve this conflict of accountability, if we have a precise and reliable location of where the driver is and what he's currently doing, is he standing or actually riding a van, when he's, you know, clicking that delivery attempt failed, we could, you know, maybe solve that problem here. But it's a tricky one. So those are just two ideas that we wanted to throw over the fence towards the crowd. And yeah, that actually brings me to the end of my presentation. I don't know if you guys are going to share the presentations in the end anyways, but if you want to snap a picture of the QR code, I'm going to be able to send you the presentation. And thank you.
Thank you, Ingo. That's amazing, like, because we talked so much about the like how to navigate the driver to the rooftop or even a closer coordinate, and now it really feels like we in the future will be able to close the gap and the gap to the front door, to the right front door. So it's amazing. I would take some questions, like first from the space this time. Any questions? Yeah.
Yeah, thanks. Yeah, great presentation. Really interesting. So just imagine one driver who is the first one at a specific address, doesn't find the address, goes to a wrong location first, and this is recorded. Afterwards, another driver follows this instruction and also goes to this location. I guess this could be a problem. So I'm curious on how do you correct yourself and the data that you have.
A good point. I think for this, yeah, you will definitely need the manual correction, but if you think of a parcel, it needs to be delivered at some point, and I think I would only, account for a location if a delivery is successful. I hope he doesn't go into the wrong location, just tosses the package and says it's successful, and then we're kind of lost. But if he's unsuccessful in an entrance that is recorded, then I would still want to record it. It's still interesting to know, but that should be a red flag. Like, don't try it there again.
I would take a remote question from Anna from Budapest. Do you record indoor events of the driver and create an indoor so-called turn-by-turn navigation, or is it just a static explanation? I would say is it a static explanation?
I wish, but I'm going to be honest, if we could do that reliably, I'd be a billionaire and I wouldn't be here. This is like one of the biggest challenges, to do reliable indoor tracking and navigation without having mapped the space before, without any extra infrastructure. I think we're fairly confident of having a precise location of the driver maybe 30, 60 seconds after he's entered the building, but then things become fuzzy. So that's something we can't do yet.
Another question from the space here. Gerion.
Yeah, thank you first of all. How do you match operational behavior to all this data that you have? Because you just mentioned you don't have your own front end, so there's not a driver saying, now I'm getting off my bike, now I'm entering a door, and I believe there must be hundreds or thousands of different data sets that you have. How do you do this matching of behavior?
Yeah. We're actually really comfortable in our little space of just being a data provider for position and motion data insights. So if you're my customer, I'm going to tell you, this is what happened. Go ahead and match that with your own data. You go and talk to the driver who wasn't there. Like, this is none of our business. But typically, to be serious here, of course, we have to take into account in what kind of databases our data gets injected. But in a classical case, you have an ID that's linked to a delivery or to an address or to a customer, and then we inject a new data set into that. Could be a timestamp that was missing before, could be a location that was missing before. But harnessing the data for efficiency improvements in dispatching, for performance management, that's really on our customer side.
And probably will be about the combination of those data and to create intelligence out of it. And that will be a really exciting field. Another question here from the space.
Thanks. That was really interesting. Do you have any issues with impact on battery, like the phone battery? Does it consume a lot of battery from the phone?
Yeah. So the trick here is to not record the whole time. If we were to do that, battery, we haven't seen as much of an issue, but also data, because through certain sections, we rely on highest possible frequency IMU data. And if we were to stream that the whole time, we'd really use up your data plan. So the key here is that we can use some simple metrics. For example, if I know I'm getting into a 250-meter geofence of the location, then I'm going to really turn up the volume, so to say. Then I'm going to really turn up the frequency. Then I'm going to increase the frequency on GNSS data, which is one of the biggest energy consumers. But for most of the journey, we can actually be fairly quiet. But there are some use cases where some customers might want to have the highest resolution of knowledge at the whole time. And then we haven't seen a huge impact on battery, but for sure it has to be accounted for.
All right, thanks very much. I would ask all the speakers to come to the front, grab a chair, and we'll have like a short sum up. Thanks, guys. This is David. Grab a chair. Maybe we need some space here. Yeah. Good. Ingo, thanks again for this look into the future. I will pass you around the microphone, so don't worry about it. As said, this combination in the future of the data of all the events that we have and that we collect, that will be amazing field. I want to bring up one topic that nobody of you guys brought up, and that's probably the elephant in the room: false positives. So, how do you guys handle it? And I just wanted to bring it up because it's when we don't know that it's a failure, we cannot handle it. It's very difficult to measure. And how do we deal with it? Octavio, let's start. I mean, you have some experience. Maybe you can also explain what a false positive is.
Yeah, so a false positive is when we have an address that seems to be correct, pretty much what Alex showed us in one of his slides. And then the geocoders say, it's actually here, but it could be that there's also another result that is relevant enough to show in this result. Then you end up having more than one single result. That's one type of false positive. The other one is, this is the result, but it's actually not the right location. So this is more or less a false positives.
Ingo, do you also have something like false positives?
I think we just had one in the discussion with the question asked. Maybe not a false positive on our side because an entrance was there and it was detected, but it wasn't the right one for the delivery. And there we basically have to rely on the question if the delivery was successful. But still, we could have the case that an entrance is detected and it's actually, like we saw on the bad data. You know, nobody's proof from bad data. But we can do one backup check, and that's that entrances are typically at the edges of buildings. Unfortunately, for many of the buildings we have edge data available in mapping database, OpenStreetMap, etc. It's not available everywhere, but it can be used fairly reliably to check that entrance that I detected that is not on the top of the building, in the backyard, wherever. So those are two checks.
Alex, of those 80% that you said exactly right, you can validly geocode. Do you know how many false positives you have in that?
No. But I would say then it's people business, because you still have got the driver. And we work with the driver and we need the driver and we rely on the driver. And so this is really important knowledge, and we must take care of that and make it available in the systems, because I think that within the false positive, the systems comes to an end currently.
Which brings me to my next topic, which is the involvement of the driver. David, we heard also from you that you accept address corrections, and I mean, you have 5,000, 6,000 not only drivers but also geocachers out there. Have you planned any incentive programs for the drivers? Because this, in the end, this data is of big value, of course.
Yes, there is incentive plans to manage these corrections, because bad quality source information, maybe it's not allowed to geocode, or just to correct these false positives as well. So just like mentioned here, so involving people and drivers is one of the shapes that we need to evolve and manage. Yeah, this kind of like the false absent fraud, just to detect or audit how much is the difference on the geocoded address and the action of the driver. So at the end is a combination of all of this.
So I want to bring up another topic that was also brought up by you, Alex. This is the dependency to the shippers or the online stores where the actual address data is entered, which is a big challenge because, like, historically, parcel delivery companies, they just accepted whatever came in, right? They had to accept. It may be different with food delivery companies. They are in full control of the complete user journey, so they can check and validate the address whenever it's entered, and then at least you can probably say the rooftop coordinate will be fine. Yeah, I just want to ask this question into the round about the future of this topic. How also in parcel delivery, where thousands, millions of addresses come in every day, how to do the quality assurance from the very top, from the very beginning, from the shippers. What are the strategies of the delivery companies behind it? David, do you have any strategy like penaltying or anything, or incentivizing the shippers for address quality?
Yeah, it's a possibility because there is actual penalties for bad labeling processes on customers. So bad quality information, not about only the address, but the quality of the contact data of the consignee impacts on the user experience because it's the way, the channel that we have to make this kind of experience. So yeah, this is just one of the activities that we can put in place.
Yeah, actually, it's a funny thing because there are heavy penalties for parcels that could not be delivered and have to be returned to the original shipper, and heavy penalties on it because it's a lot of additional manual work. But do you have any strategies of like creating other penalties that catch this problem on a more early stage?
I think you have to make it transparent to the retailers what the problem is, and then you have to speak about it first, because the penalty is quite a really hard issue you take in place, and the retailer also wants to create a good customer satisfaction in the end. So if he knows it and he has it transparent, then he really wants to work on it. And I think personally you can do it without any penalties if you make the problem transparent first, and then in the end, if it does not work, then you might take some penalties in place, but first you have to talk.
I mean, it is a common interest of both parties involved to get the pack delivered, and maybe it's also a matter of education, that how important address data is. But tell this to a shipping customer that has their ERP system and has the same addresses in there for the last 10 years to work on it. It can be difficult, right? So not every shipper is an online shop. So that will be a big challenge in the future. Ingo, you showed us today how to close the gap also for parcel delivery companies in the future. I'm really looking ahead to also to working with you and to learn. But you are very experienced in this field. Our dreams are high, but where are the limits?
I think one of the limits currently is that one question that was asked, indoor navigation. Also, I think from privacy standpoints, right? You want your shipper to arrive in front of your building, but maybe you don't want a step-by-step navigation to insides of your building. I think it's good to keep this limit for now. But I think we can get so much better by sharing information. And I want to link to something that I think I saw Octavio post on LinkedIn not so long ago. You know, you guys are all solving these questions every day. The food delivery companies are solving these questions every day. And if people have solved them before, wouldn't it be great if we could, access a common database? And I think there's really huge potential in that, because right now these things are solved by individual drivers, and then they're not going to make the mistake again, but the next driver on the next shift is going to make the mistake again, and the next driver from another company is going to make the mistake again for sure. And I think that can be avoided.
Yeah, I think that is perfect also for a closing. Partnership is the key. That's why we initiated here this meetup. We need not only to share information, we need to partner, we need to cooperate, because otherwise these data will get collected by others and will be out of our hands. So it is essential that that we do this. Thanks everyone for coming here, making this again a success. I hope it was interesting for you guys. You take a lot of information with you. Everyone on the screens at home, thanks for holding through. I hope you also, next to the great speeches, had a couple of beers with it, and that's exactly what we will do right afterwards, after switching off the microphone. Thanks to the speakers today. I want you guys here in the space ask you for clapping your hands to these fantastic speakers. Thanks everyone for coming here. Reminder, please sign up for the Bettermile newsletter and follow us on LinkedIn to be informed about industry news and the next meetup. See you there. Have a great time. Thank you.